In last lecture, we have studied Hofmann rearrangement reaction. Now, what is meant by Hofmann rearrangement reaction? Suppose this is one of the important functional group from the organic compound R, C double bond O, NH2, and this is nothing but amide. When this amide is created with the alkaline hypohalide, that is mixture of alkali and halogen, that mixture is called alkaline hypohalide. That reaction is carried out at high temperature. Now here, this amide is converted into the corresponding RNH2, and thus amide is converted into primary amine, which having one carbon atom less, and this reaction is called Hofmann rearrangement reaction. We have studied mechanism of this reaction, means actually how the rearrangement occurs, what are the intermediates formed during that reaction. For example, there is a formation of nitrene, isocyanate, and also there is a migration of alkyl group takes place from carbon to the electron deficient nitrogen. We have studied the detailed reaction under the heading mechanism, and we also studied some of the example, some of the applications of this particular reaction. Now let us see next one of the important reaction, and this is nothing but the Wittig reaction. आपण पुढची रिएक्शन या ठिकाणी स्टडी करतोय, and this is nothing but the now let us see a general example first. I will explain a general example. R C double bond O R. Okay, this is nothing but just a carbonyl compound. It may be aldehyde or it may be ketone. Now when this carbonyl compound, it may be aldehyde or ketone, is treated with a specific reagent. Okay, this is a specific reagent. P means phosphorus. That phosphorus is attached to the CH2 by double bond, and also 3-phenyl group. That pH means phenyl group. This pH means phenyl, means there is a benzene ring. There is 6-membered ring, and such 3-phenyl group I have written in short pH. pH indicates phenyl. Phenyl means benzene ring, 6-membered cyclic ring. Okay, such 3-phenyl groups are attached to that phosphorus, and this compound is called phosphorus ylide. That reagent is called phosphorus ylide, and it is a very important reagent widely used in our organic synthetic reactions. And when that carbonyl compound is created with that phosphorus ylide, in phosphorus ylide, phosphorus is attached to the CH2 by double bond, and also that phosphorus having 3-phenyl groups, 3 benzene rings are attached to that phosphorus, and this is called phosphorus ylide. Okay, now our carbonyl compound, when it reacted with that phosphorus ylide, that reaction is carried out in presence of ether. Now what happens here? This is very simple reaction. Here that oxygen is replaced by CH2 group. Oxygen is replaced by the CH2 group from the phosphorus ylide, and we get the corresponding compound. There is a C double bond CH2, replacement of oxygen by CH2, and we get corresponding alkene. This is substituted alkene. There is a formation of substituted alkene, and what is the byproduct? Now the CH2 group is replaced by this oxygen. Means there is exchange between. We can simply say that there is exchange between CH2 and oxygen. इथं actually काय होतं reaction मध्ये? There is exchange between oxygen and CH2. Means oxygen replaced by CH2 and CH2 replaced by oxygen, and we get the byproduct. This is the P double bond O, means replacement of CH2 by oxygen. Okay, thus in this reaction, our carbonyl compound, our aldehyde or ketone, convert into corresponding substituted alkene. Why it is substituted? Because that carbon, this double bonded carbon having 2 alkyl groups, therefore it is substituted alkene actually. In this reaction, carbonyl compound, that is aldehyde or ketone, when treated with the phosphorus ylide in presence of ether, we get corresponding substituted alkene. In this reaction, oxygen from the carbonyl compound is replaced by CH2 group, and we get corresponding, yes, we get corresponding substituted alkene. And this reaction is called as the, yes, this reaction is the Wittig reaction. This reaction is called Wittig reaction, and in this reaction also there is a conversion of one functional group. One functional group means carbonyl group. There is a conversion of C double bond O group into alkene group into olefin. Alkene is called olefin. There is double bond. It is called olefin. Means carbonyl group is converted into olefin. Carbonyl group is converted into substituted alkene. Aldehyde or ketone convert into corresponding alkene. And this is again a very important reaction, because here there is a conversion of one functional group into another functional group. There is a conversion of one functional group into another functional group. Carbonyl compound converts into substituted alkene. Okay, let us see in detail about this reaction, Wittig reaction. This is the Wittig reaction, and very, very important reaction, very commonly used in organic synthesis, in so many organic conversion for the conversion of carbonyl compound into corresponding substituted alkene. Okay, let us see. First, we will see what is meant by phosphorus ylide. In detail, we will see about that reagent. Okay, this is our reagent. Phosphorus is attached to the CH2 by double bond. It having 3 pH group. pH means phenyl group. Means there are 3 such benzene rings. 3 such benzene rings are attached to that phosphorus. Therefore, we can write in short PS3, P double bond CH2. Okay, this is actually phosphorus ylide. Now, what should be the name of compound? Actually, this compound is the alkylidine. Alkylidine means this group. Alkylidine. Okay, this is alkylidine triphenyl. Okay, there are 3 phenyl groups. Therefore, it is triphenyl phosphorane. Thus, phosphorus ylide is nothing but the alkylidine triphenyl phosphorane. म्हणजे alkylidine triphenyl phosphorane असेल, that's compound, that reagent is called phosphorus ylide. अशा कंपाऊंडला किंवा अशा रिएजंटला आपण phosphorus ylide असं म्हणतोय, and it is also known as Wittig reagent. It is also named as a Wittig reagent, and this reaction is called Wittig reaction. This is just about the particular reagent which is used in the reaction, what is meant by phosphorus ylide. Okay, now I will explain once again how that Wittig reagent is prepared in laboratory. We will see how that reagent, how that phosphorus ylide is prepared in laboratory. The starting material used for the preparation of Wittig reagent is a triphenyl phosphine, PS3. PS3 means 3 phenyl groups are attached to the phosphorus. It is called triphenyl phosphine. When this triphenyl phosphine is treated with the methyl bromide, CH3Br, this is methyl bromide, a common organic compound. Here, what happens in this reaction? Here, phosphorus having a lone pair of electron. Now, this phosphorus form a bond with this methyl group. It form a bond with that carbon. There is a lone pair of electron. Now, this lone pair of electron from the phosphorus form a bond with that methyl group. It form a coordinate bond with the methyl group, and we get actually, okay, thus it donates this electron pair to the carbon and form a bond with that carbon. Now, simultaneously, a bond between carbon and bromine. This bond undergo breaking. Electron pair goes towards bromine. It acquire negative charge. Means in this process, there is a formation of new bond between phosphorus and methyl group. Simultaneously, a bond between carbon and bromine undergo breaking. There is a breaking of bond between carbon and bromine, and there is a Br minus. Okay, what is the byproduct? Br minus actually. Okay, this is the byproduct, and new bond between methyl group and phosphorus. Okay, this is the new bond between methyl group and phosphorus. Now, during that process, phosphorus donate its electron pair, hence it acquire positive charge. And Br having negative charge, and there is a formation of PS3, P phosphorus having positive charge, and it having a bond with methyl group, and there is Br minus. This is called phosphonium salt. We are discussing about the preparation of Wittig reagent. We are discussing about how the phosphorus ylide, how that reagent is prepared. म्हणजे आपण Wittig reaction मध्ये, in Wittig reaction we are using a specific reagent. We are using alkylidine triphenyl phosphorane. आणि इथं आपण काय स्टडी करतोय? How that reagent, how that phosphorus ylide is prepared in laboratory. Okay, we are using triphenyl phosphine as a starting material. This is triphenyl phosphine. When it is treated with methyl bromide, phosphorus having lone pair of electron, it form a bond with that methyl group. Simultaneously, bond between carbon and bromine undergo breaking. This electron pair goes towards bromine. It acquires negative charge. Okay, this is Br minus, and this is the new bond between phosphorus and methyl group, while phosphorus having positive charge. Okay, this is our phosphonium salt. Now this phosphonium salt, okay, I have written that phosphonium salt PS3P having positive charge. There is a methyl group CS3. But here I have shown one hydrogen separately just for convenience to understand the reaction. Okay, this is our phosphonium salt. There is Br minus as it is. Okay, same reagent, same intermediate phosphonium salt I have written in the second line. Now this phosphonium salt, what happens when it is treated with the strong base? In the second step, we are using a strong base. For example, phenyl lithium. Phenyl lithium is example of strong base, and when that phosphonium salt comes in contact with the phenyl lithium, it loses that hydrogen. It loses that hydrogen. Base having tendency to abstract that hydrogen. And here in this step, a bond between this carbon and hydrogen undergo breaking. This bond undergo breaking. There is a formation of pi bond between phosphorus and carbon. There is a formation of new pi bond between phosphorus and CH2 group. म्हणजे इथला हा bond break होतो, bond between carbon and hydrogen. This bond undergo breaking, and this electron pair form a bond between phosphorus and CH2, and we get the reagent PS3P double bond CH2, and this is nothing but our phosphorus elite. Now there is a loss of H plus ion. इथून काय बाहेर पडेल? H plus ion. We can say that H plus ion and that Br minus, it forms HBr. We can simply say this is the byproduct HBr actually, and we get the main reagent, main species, and this is nothing but our phosphorus elite, and it is also called as the Wittig reagent. Okay, now in this step, in this slide, we have studied how the phosphorus elite is prepared. We are discussing about the Wittig reaction, but in the first step, in the initial step, we are discussing what is meant by phosphorus elite, how that phosphorus elite is prepared, to कसा तयार करतो, आणि आपण त्या phosphorus elite बद्दल थोडंसं माहिती बघतो आहोत. Now let us see one more information. This is our phosphorus elite PS3 P double bond CH2. Now that species also undergo delocalization. It also undergo delocalization, means it shows resonance effect. It shows resonance effect. Resonance is nothing but the delocalization of pi electron. How there is a delocalization? Here there is a pi bond between phosphorus and CH2. Now this electron pair goes towards carbon. Carbon acquire negative charge and phosphorus acquire positive charge. Okay, this is the resonating structure of phosphorus elite. Okay, both are the phosphorus elite. We can write phosphorus elite in the two manner. दोन्ही प्रकारे आपण दाखवू शकतो. Okay, phosphorus having double bond with CH2, or simply phosphorus having positive charge and carbon having negative charge. Both are the phosphorus elite. They are the contributing structures. They are the resonating structures of phosphorus elite. Okay, this is just about the, we can simply say that in last sentence, phosphorus elite is a resonance stabilized because there is a delocalization of pi electron. Okay, this is just about the phosphorus elite. We have studied what is meant by phosphorus elite, then how it is prepared in laboratory, and lastly how it shows the resonance effect. तो resonance effect सुद्धा कसा दाखवतो हे सुद्धा आपण बघितलेलं आहे. Now let us see about the Wittig reaction. आपण पुन्हा एकदा Wittig reaction कडे जाऊया. I will take another example. Actually, in the first step, in the first slide, we have studied a simple example of Wittig reaction. I will take one more example. Okay, this is again example of carbonyl compound. PH C double bond OPH. PH means phenyl group. The name of this ketone, this is example of ketone actually. The name of this ketone is a benzophenone. We can take any ketone. We can take any aldehyde. We can take example of acetone. We can take example of butanone. We can take example of acetophenone. Any aldehyde or ketone we can use instead of that benzophenone. Okay, this is the benzophenone example of carbonyl compound, example of ketone. When this compound is treated with, suppose our Wittig reagent PS3 P double bond O CH2. Okay, this is our phosphorus elite. This is our Wittig reagent. That reaction is carried out in presence of ether. Now, what is the reaction? Yes, very simple reaction, that oxygen is replaced by CH2 and CH2 is replaced by oxygen. Means there is an exchange between oxygen and CH2, and here we get PHC double bond CH, PHC PH double bond CH2. Okay, this is our substituted alkene. Okay, this is our substituted alkene, and byproduct is the PS3P double bond O. And thus, in this reaction, benzophenone is converted into corresponding substituted alkene. What is the name of this substituted alkene? Okay, here there are two carbon. Here there are two carbon. Means parent alkene is a ethene. Parent alkene कोणता आहे? Ethene. Now, one carbon having two phenyl group. एका कार्बन वरती दोन फिनिल ग्रुप आहेत, म्हणून याला आपण काय म्हणू शकतो? वन डायफिनिल इथिन. One diphenyl ethene. This is the name of that alkene, and thus benzophenone converts into corresponding alkene, and this reaction is Wittig reaction. In this reaction, we have used a phosphorus ylide. We have used a Wittig reagent. Okay, this is just a conversion of one functional group into another. This is just conversion of carbonyl group into olefin, that is double bond, C double bond C. Okay, and this is again a very important reaction because there is a conversion of one functional group into another. Let us see mechanism of this reaction. What is meant by mechanism? Yes, detailed study about the reaction, how that conversion occurs, how there is a conversion of benzophenone into ethene takes place, how that carbonyl compound converts into corresponding substituted alkene, what are the intermediates formed during that reaction, how the bonds undergo breaking, how there is a formation of new bond. Let us see mechanism of this reaction. Okay, I will explain the mechanism of this reaction, actually, how that reaction takes place. Okay, let us see starting material used for the that reaction. Yes, we are using phosphorus ylide. This is our phosphorus ylide, PS3P double bond CH2. We can write in the two manner. We can write that phosphorus ylide in the two manner. One is the PS3P double bond CH2. किंवा आपण काय म्हणू शकतो? Phosphorus having positive charge and carbon having negative charge. Okay, this is our phosphorus ylide. Now this phosphorus ylide in first step react with carbonyl compound. I will take a general example. R C double bond O R. This is our carbonyl compound. Just for convenience to understand the reaction, I will write. I have written that phosphorus ylide, and this is the ketone. This is the example of carbonyl compound. Now, what happens in the first step? Actually, in the phosphorus ylide, carbon having negative charge means there is an electron pair. Therefore, this phosphorus ylide acts as a nucleophile. It acts as a nucleophile. Now, our carbonyl compound, this carbon is electron deficient. Therefore, what happens? That negative charge means electron pair. This electron pair form a bond with that carbonyl carbon. This electron pair attacks on that phosphorus ylide attacks on the carbonyl carbon of that aldehyde or ketone. या aldehyde किंवा कीटोनच्या carbonyl carbon वरती या न्यूक्लियोफाइलचा अटॅक होतो. There is a negative charge means electron pair. This electron pair form a bond with that carbon, means there is a formation of bond between these two carbon. Now, to maintain the valency of this carbon, to maintain the valency of carbonyl carbon, one of the pi bond undergo breaking, this bond undergo breaking, and electron pair goes on the oxygen. ही electron pair oxygen कडे जाते आणि या दोन्हीच्या मध्ये there is a formation of new bond between these two carbon, and we get the intermediate. Okay, this is new intermediate. This is the new bond between two carbon. Okay, here there is a breaking of pi bond and oxygen acquires negative charge. Because this pi bonded electron pair goes towards oxygen, it acquires negative charge. Okay, we get the intermediate, and this intermediate is called betaine. This intermediate is called betaine intermediate. Okay, now this betaine intermediate undergoes cyclization. It undergoes cyclization. Here, oxygen having negative charge means there is an electron pair. Now, what happens? This electron pair of oxygen form a bond with phosphorus. Because phosphorus is electron deficient, it having positive charge. Therefore, this electron pair form a bond with phosphorus and we get the four-membered cyclic compound. We get the four-membered. Here this negative charge electron pair form a bond between oxygen and phosphorus and we get the cyclic compound, four-membered cyclic compound. Okay, this is the new bond between phosphorus and oxygen. This is the new bond between phosphorus and oxygen and we get the cyclic compound, and this cyclic compound is called oxaphosphetane. This is the oxaphosphetane, and thus in the second step we are having a cyclic compound called oxaphosphetane. Now let us see next step. Okay, this is our oxaphosphetane. Now what happens in the next step? In the next step, some bonds undergo breaking and some new bonds are formed. In next step, some bonds undergo breaking and some new bonds are formed. Now let us see how the bonds undergo breaking. Let us see how the bonds undergo breaking. Here, first step, this is our oxaphosphetane. Okay, in first step, okay, this bond between carbon and oxygen, this bond undergo breaking, and there is a formation of new pi bond between phosphorus and oxygen. This bond undergo breaking, and there is a formation of new pi bond between phosphorus and oxygen. Simultaneously, bond between phosphorus and carbon, it undergo breaking. Yeah, bonds are breaking hota, and there is a formation of new pi bond between two carbon atom. There is a formation of new pi bond here between two carbon atom, and we get the product. This is our product R. Then again C, double bond CS2 and second R group. Okay, and thus there is a formation of R, C double bond CH2R, and this is nothing but the substituted alkene. This is our substituted alkene. This is our expected product. Now, what is the byproduct? Okay, this is PS3, P double bond O, PS3, P double bond O, and this is the byproduct. And thus, in this reaction, carbonyl compound. In this reaction, that carbonyl compound converts into corresponding substituted alkene. It converts into corresponding substituted alkene. Okay, and this is just a 1, 2, and 3 step reaction. This is just 1, 2, and 3 step reaction. I will explain once again the mechanism. This is very important step actually. Generally, question may be asked, what is meant by Wittig reaction? How the Wittig reagent is prepared? Then explain mechanism of Wittig reaction. म्हणजे Wittig reaction म्हणजे काय, त्यानंतर Wittig reagent किंवा phosphorus ylide कसा तयार करतो हे पण विचारलं जाईल. And finally, mechanism of this reaction. Okay, mechanism is very important term. I will explain. Okay, this is our phosphorus ylide, PS3P, phosphorus having positive charge, carbon having negative charge. This is our phosphorus ylide. In first step, it react with our carbonyl compound. Phosphorus in phosphorus ylide, carbon having negative charge, means it act as a nucleophile. It attack on the carbonyl carbon. It form a bond with carbonyl carbon. To maintain the valency, one of the pi bond undergo breaking. This electron pair goes towards oxygen. It acquire negative charge and we get the intermediate. This is a new bond between two carbon. While this pi bond undergo breaking and there is a negative charge on the oxygen, and this intermediate is nothing but the betaine intermediate. This intermediate is called betaine intermediate. Now this betaine intermediate undergoes cyclization. Here oxygen having negative charge, it form a bond with that positively charged phosphorus. There is a formation of cyclic compound, and this is the cyclic compound called oxaphosphetane. This is the oxaphosphetane. Now in the next step, in the third step, what happens? This is our oxaphosphetane. It undergo sequential breaking and making of bond. Here some bonds, two bonds undergo breaking and two pi bonds are formed. दोन बॉन्डचं ब्रेकिंग होतं आणि दोन नवीन पाय बॉन्डचं फॉर्मेशन होतं नेक्स्ट स्टेप मध्ये. लेट अस सी हाऊ द बॉन्ड्स अंडरगो ब्रेकिंग. हियर द बॉन्ड बिटवीन कार्बन अँड ऑक्सिजन, इट अंडरगो ब्रेकिंग. Formation of pi bond between phosphorus and oxygen. Simultaneously, this bond undergo breaking. There is a formation of bond between two carbon, pi bond formation between two carbon, and we get the compound. Okay, C double bond CS2 and R. This is substituted alkene, and byproduct is the PS3P double bond O. Okay, this is just mechanism of this reaction. We have studied actually how that carbonyl compound, how the aldehyde or ketone converts into corresponding substituted alkene. Okay, this is very, very important reaction. Okay, before that, या अगोदर आपण काय स्टडी केलं होतं? Before that, we have studied preparation of Wittig reagent. त्यामध्ये आपण Wittig reagentचं प्रिपरेशन आपण स्टडी केलेलं होतं. आणि लास्टली we have studied the mechanism. Now let us see some applications of this reaction. याचे applications आपण बघणार आहोत. Applications मध्ये आपण actually काय स्टडी करतो आहोत? Some of the examples we are just discussing about some of the examples of this particular reaction. Let us see simple example of ketone. This is cyclohexanone. This is cyclic ketone, cyclohexanone. When this compound is created with the PS3 P double bond CS2, this is our phosphorus ylide. Now same type of reaction is there, that oxygen should be replaced by CH2 group. This oxygen is replaced by CH2 group, and there is the formation of corresponding compound. This is substituted alkene. Byproduct is the same, PS3 P double bond O. Okay, this is actually substituted alkene. And here this methylene group is outside the cycle. This is also called as the exocyclic methylene group. This is exocyclic, म्हणजे मिथिलीन ग्रुप आहे पण सायकलच्या बाहेर, म्हणून त्याला एक्झोसायक्लिक असं म्हणतोय आपण. देयर इज अ मिथिलीन ग्रुप प्रेझेंट इन द मॉलिक्यूल, बट इट इज आउटसाइड द सायकल, इट इज आउटसाइड द रिंग. Hence such compounds are called exocyclic methylene group, that compound having exocyclic methylene group. Okay, and we can prepare that exocyclic methylene group compounds by using this reaction. Okay, now again simple example of this reaction. Let us see one more example. Okay, this is our RC double bond OR. Again general example I have taken, but here the phosphorus ylide is sometimes different. Okay, this is actually our phosphorus ylide. This is our phosphorus ylide. PS3P having positive charge, carbon having negative charge. This is our phosphorus ylide. But suppose one of the hydrogen atom, yes, CH2 madla ek hydrogen atom I have replaced by CH2COOH group. One of the hydrogen is replaced by CH2COOH group. This is substituted phosphorus ylide. We can take, for this reaction, we can take substituted phosphorus ylide. We can take substituted Wittig reagent. Okay, here this is example of substituted Wittig reagent. Now our carbonyl compound, when treated with the substituted phosphorus ylide, we are having same type of reaction. म्हणजे इथं काय होतं, that oxygen is replaced by whole this group. या पूर्ण ग्रुप ने रिप्लेस होतो. Oxygen is replaced by whole this group, and there is the formation of this compound. Okay, double bond CH, single bond CH2COOH. Right? Means here reaction is in the same manner, but instead of plain phosphorus ylide, I have taken substituted phosphorus ylide. Byproduct is again same, PS3P double bond O. Okay, and thus we can take substituted phosphorus ylide also. Again consider the example. This is again same, yes, cyclohexanone, cyclic example of cyclic ketone. When this cyclohexanone is treated with the substituted phosphorus ylide, okay, this is our phosphorus ylide. We can write in this manner also, किंवा आपण त्याला पॉझिटिव्ह निगेटिव्ह असं दाखवू शकतो, किंवा युजिंग डबल बॉन्ड. Okay, these are the actually resonating structures of each other. Instead of writing double bond, we can write positive and negative charges. Here that hydrogen is replaced by chlorine. This is example of substituted phosphorus ylide. When it is treated with that cyclic ketone, same type of reaction occurs, and that oxygen is replaced by CHCl group, and we get corresponding substituted alkene. Okay, again this is the example of Wittig reaction. Now consider one more example. We can take example of aldehyde also, C6H5. C6H5 means again phenyl group, benzene ring is there. That compound is called benzaldehyde. This is example of aldehyde. Okay, this is the benzaldehyde. When now similar to ketone, आतापर्यंत आपण example बघितलं की ketoneचा, but similar to ketone, aldehyde also undergoes same type of reaction. When benzaldehyde is treated with the any phosphorus ylide, I will take the same example. मगाशी आपण बघितलं होतं substituted, तेच example आपण घेऊया. Here also that oxygen is replaced by CHCl group. या ग्रुप ने रिप्लेस होतोय, and there is the formation of corresponding substituted alkene. that hydrogen is replaced by this group. या ग्रुपनं ऑक्सिजन रिप्लेस झालेला आहे and we get the substituted alkene. Okay, this is just example of this particular reaction. Okay, we are just discussing about the Wittig reaction. Actually, Wittig reaction is one of the important reactions from the organic chemistry. Why it is important? Because in this reaction there is just conversion of one functional group into another functional group. या रिएक्शन मध्ये आपण एका फंक्शनल ग्रुपचं कन्वर्जन दुसऱ्या फंक्शनल ग्रुप मध्ये करतो आहोत. म्हणजे कार्बोनिल कंपाउंड इज कन्वर्ट into olefin, the aldehyde or ketone is converted into substituted alkene. Therefore this is very important reaction.